Consider a set of processes with arrival time, CPU burst time and priority. 0 is the highest, shown below. None of the processes have IO burst time. So we are given this table of processes P1 to P5 with arrival time, burst time and the corresponding priority. The average waiting time of all the processes using preemptive priority scheduling algorithm is. So this is a question from operating system regarding process scheduling. So here they are saying the scheduler used this preemptive priority scheduling algorithm. So preemptive priority scheduling means while a process is running, if another process having a priority greater than that comes in, at that time that running process would be preempted and the higher priority process would be given the CPU. So let us try to see how the scheduler will proceed. At time 0 only P1 is there, so we will start running with P1. At time 2 P4 will arrive. Now if you see, P1 has priority 2 and P4 has priority 1. In the question it was given that 0 is the highest priority, so meaning 1 is higher priority than 2. So we will preempt P1 and we will start running P4. So at time 2 P4 will start running. At time 5 P2 arrives and P2 has a priority of 0. 0 is the highest. So at time 5 P2 will start running. So if you look at the processes, P2 has the highest priority. No other process has a priority higher than P2. So P2 will keep on running uninterrupted till its burst time is over. So P2 started running at 5. It had a burst time of 28. So it will keep on running for 28 more cycles. So that is 5 plus 28. So P2 will keep running till 33. At this point P2 will be over. Now at 33, when the time is 33, you can see P3 and P5 both will have arrived by now. So we can just look in the processes and choose the highest priority process and just run that. So P2 is over. After that the process with the highest priority is P4 having priority 1. So we'll start running P4. So if you see, P4 already ran from 2 to 5, that is for 3 milliseconds, and total burst time is 10. So P4 will need to run an additional 7 milliseconds. 3 already we completed, total is 10, so 10 minus 3, 7 additionally it needs to run. So from 33 to 33 plus 7, P4 will run, that is up to 40. By this time P4 is over. We'll choose the next process with the highest priority, that is P1 having priority 2. So we'll start running P1. P1 will keep on running till 49. Because P1 already ran for 2 milliseconds, total was 11, so we needed 9 additional. So P1 will keep running till 49. After that, the process with the next highest priority is P3. P3 will run for 2 milliseconds. So 49 to 51, P3 will run. After that, P5 will run. P5 had the lowest priority. Now we will run P5 for 16 milliseconds. So starting from 51, for 16 milliseconds it will run, meaning till 67, P5 will run. Now let us calculate the waiting time for each of the processes. Waiting time of a process is given by the formula completion time minus arrival time minus the burst time. So completion time minus arrival time is the total turnaround time of the process. Turnaround time minus the burst time gives the waiting time of that process. So for P1 completed at 49, P1 arrived at 0. So turnaround time is 49 minus 0. And P1 had a burst time of 11. So this minus 11 gives 38. Similarly, I have calculated the waiting time for P2, P3, P4 and P5 based on this table and whatever value I can see in the chart drawn here. So average waiting time is 38 plus 0 plus 37 plus 28 plus 42 divided by 5. That will give you 29. 29 is the answer.